Hey guys, today we're going to start our journey with three-dimensional figures, and we're going to start talking about a rectangular prism. Now, rectangular prisms can be found all over, okay? They basically look like big boxes. Alright, so for example, we have a tissue box here, okay? Rectangular prism. Or as another example, we have this crate. Okay, this crate. It's 3 dimensions here. Okay. So when we start talking about our three-dimensional figures, and we're going to move into surface area in just a minute, what we want to start talking about is what do these figures look like if we were to cut them open and lay them flat. That's what we call a net. Okay? A net is basically that three-dimensional shape flattened out, laid out, and what would it look like? Okay, so this is just one example of what a rectangular prism could look like. Okay? It's got 4 longer faces and then 2 side faces to kind of close up the sides of the box. And as an example, let me pan out here. Okay, we could take this tissue box here, okay, and again, it's got its 4 faces and its 2 side faces to kind of cover it up, close it up. And so the question you might be asking is, why are we actually studying surface area and these three-dimensional shapes? Well, a good answer for that is if you go into marketing as a future, okay, and you have a box that looks like this, companies look at how much it will cost for them to cover this box, okay, this surface area, with the pictures and information that is on it. Okay. Another example would be wrapping a gift. For example, say I wanted to wrap this tissue box. I think everyone would be really excited to get a tissue box. But if you wanted to wrap this up for like a birthday or something, how much wrapping paper would you need? Okay? So, talking about surface area, and I need to pan in. So surface area is the total sum of the area of an object's faces. Okay? So we talked about like on the tissue box, the 4 longer sides and then the 2 smaller sides to kind of close up the box. What is the area of those faces? Okay? And even though we're working with a 3-dimensional object, okay, we are still working with area, and area is a 2-dimensional measure. Okay, so there is a formula that we can use to help us with this, and that is 2 times the length times the height, and 2 times the length times the width, and 2 times the height times the width. Okay, and we can kind of shorten that down to 2 times L times H plus 2 times L times W plus 2 times H times W. So we add up the area of 2 sides of each side, and that will get you the total area of the figure. Alright, so first example I'm going to give is in a net form. Okay? And so here we have our length of 5. You can see the long sides are 5. And then we have our varying heights and widths of 1 and 2 respectively, okay? So on this side here, this would be a length of 5 times a width of 1. And so that total area for this face would be 5. And then we have a length of 5 and a height of 2. So 5 times 2 would give me an area of 10 for that one. Okay, we're on to the other smaller side here. So the length here and the width of 1 would give me a measure of 5 there, an area of 5. And then for the other face, the longer face, 5 times 2 again would give me 10. And then we look on the 2 side flaps. Okay, we have a height of 2 and a width of 1, which would be an area of 2. And the same thing over here, a height of 2 and a width of 1, which would give me an area of 2. We then take all of the measures, which I have circled in black, okay, the face that's 5, the face that's 10, the face that's 5, the face that's 10, and then the 2 side flaps, which are 2 and 2 respectively. Okay, add all those up, and for this case we would get 34 units squared. So that would be one way to solve a surface area problem. Another way to do this, okay, say you're given a figure that looks like this. We're given just the actual rectangular prism. So we have a width of 7, a height of 6, and a length of 10. So we can do the width times the height times 2, 7 times 6 times 2, which would give us 84. And then we can do the height times the length times 2, so 6 times 10 times 2, which is 120. And then we can do the width times the length times 2, so 7 times 10 times 2. And if we take those measures of those sides, 84, 120, and 140, add them together, we get 344 units squared. Okay, so there's one last example. I've done it with both the net and the prism, rectangular prism. Okay, I have the net over here. We have the face that's 8 times 4. Okay, 8 times 4 because there's 2 of them, times 2, which is 64. And then I have 8 times 6, and there are 2 of these, so 8 times 6 is right here, which is 96. And then I have the 2 side flaps, kind of close up the three-dimensional shape, 6 times 4 times 2, which is 48. And I can add those together, 64, 48, 96, and get 208 units squared. And then if I look down here, it's the same numbers, the same shape, I just have it closed up. So I have 4 times 6 times 2, and 6 times 8 times 2, and then 4 times 8 times 2, again, which would give me 208 units. All right, so we are going to do a lot of practice with this in class. I know that this is going to be a little challenging for some of you to wrap your heads around. So we just be prepared to get a lot of practice in, and we will see you in class. Oos.